Okay, 724, can I calculate the slope at a point? So in the previous lessons, we investigated the average rate of change over different intervals. Okay, so in this lesson, how do we calculate it at a specific point? So the dirt bike problem in the very first chapter received a request and they need your help. So Surfer Pro spends his off-season tearing up dirt bike courses along the southern coast. He thinks that the piece of your course defined by the sine of pi x from -1 to 1 is not worthy of his time unless it has a slope of pi at some point. He does not believe that a slope of pi is anywhere and vows to chirp his followers to never visit your dirt bike track unless you can prove him wrong. So first thing, we need to graph this y equals the sine of pi x. So we actually have a tool here. It's graphed for us. So I'm going to pull this up. So we have this sine of pi x, right, from -1 to 1. So there's our sine graph. Okay, and says what's the average slope on that interval. So average, right, is from -1 to 1. So -1's an x, 1's an x, right? And we need those y values. So if we plug those in, right, we get 0 and 0, and we have a slope of 0 over 2 or 0 slope, right? It's flat. So if you go look at this graph, right, and we put these points at the end, if I can get this to work, right, and at the end, we get that 0 slope, right? And I can't quite get it. There it goes. So we get a 0 slope. Okay, so what's the average slope from -1 to 0.5? Right, so again, we're plugging this in. It's -1, 0. 0.5 is pi over 2, which gets us a value of 1. So this would be 1 minus 0 over 0.5 minus -1, or 1 over 1.5, which is just 2/3. Okay, so there's that, right? Still not pi, right? Pi is 3.14, so still not a big enough slope yet. So as a team, investigate the graph. Where might the slope be exactly pi, right? So if we look, where's our steepest slope going to be? Our steepest slope is going to be right here, right? It's going to be at 0. Or at the very beginning or very end. So 0 would be our steepest slope. And D says, Sonny does not care if he's going up or down. He only cares about magnitude. Where's the magnitude of the slope pi, right? So we have to do this as we're getting close and closer to pi, or closer and closer to 0. So like we could do, -0.001, and we could do 0.001 and plug those in. And calculate slope. So let's see what happens here when we plug these in. So you would need a calculator to do this. Make sure that your calculator is in radian mode because you're using pi. But if you do the sine of let's do -0.001 times pi, right? And we get a -0.000055. All right, and then if we do this again, but this time we don't make it negative, we get 0.000055. So we'll do that. 0.000055 minus a negative 0.000055 over 0.001 minus a negative 0.001. Okay, and then so my calculator must not be in radian mode, and I just told you guys to check that, right? It is not. It is in degree. Let's go back up and grab these. Do this again. So if we use, let's use 0 as one of them. So if we use 0 as a point, and then what's the sign at 0? It's 0. And then So we should right? Like if we're looking at this, let's do this. Let's go here and let's look at this. Right? What happens? We'll see our slope here. Right? What happens as the slope gets closer to 0? We do it this way. Right? And we see 3.14. Right? So our slope right there at an h of 0.01, right, should get us a slope of 3.14. I'm not sure exactly what's happening as far as that goes, in the sense of why my calculator's spitting out that number. So we should be able to do 0 and then point 001, right? And then if we plug that in, right, 0 times pi is 0, and then the sign of 0 is 0, right? And then we should be able to do pi times 0.001, right, which gives us like, point 0.003142. That's better. And then when we do divide those, we should get like 3.14, which is approaching pi. Okay? So now let's look at 108. In the previous problem, we calculated average rate of change over a smaller interval. Right? Now let's investigate average rate of change of f of x squared. All right, so let's do that, right, by calculating slopes of secant lines. So 2 and 3. So we have 2, 4, and 3, 9. So this would be 9 minus 4 over 3 minus 2, or 5 over 1. So we have a slope of 5. Okay, what if we do 2, 4, and 2.1? Right, so if we do 2.1, so that's 2.1 squared, we get 4.41. So you do 4.41 minus 4 over 2.1 minus 2. We'll get 0.41 over 0.1, which is going to be 4.1. All right, we're going to do this again at 2, 4, and 1.99. So if we do 1.99 squared, we get 3.9601. Again, take your slope. 3.9601 minus 4 over 1.99 minus 2. This is negative 0.0399 over negative 0.01. And if we divided those, you should get 3.99. Right? What do you notice about the intervals? They got closer and closer together, and the slopes are approaching 4. So they're getting really close to 4. Okay, 109. In the previous problem, you calculated slopes of secant lines. Now focus on the secant lines themselves. Use it to investigate what happens when h approaches 0. So look at here, looking at this problem. Okay? The first time we did it at 2 and 3. And you draw a secant line. Again, a secant line is like this, guys. Like, that's a secant line, right? So I have those points apart, right? And you can see the secant line there. But as they get closer and closer together, right, as that h approaches 0, we get more of a tangent line, right? So what is happening to the secant lines as h approaches 0? It's becoming a tangent line. And that's what 110 goes on to say. The secant line approaches a tangent line that grazes or touches the graph. When this occurs, the average rate of change approaches an instantaneous rate of change. And so how are instantaneous rate of change and tangent line at a point related? Like, they're the same. When you get a tangent line, the slope of the tangent line is the instantaneous rate of change. Okay? So now, how do we calculate that? So that's why we needed limits first. So let's look at 211. So you got 2t to the third. Show that the average rate of change of between 2 and 2 plus h. Okay, so here's how we do this. Okay, at 2, what's our point, right? If we plug in 2 cubed is 8 times 2 is 16. All right, and then 2 plus h is going to be harder. Okay, because you're going to have to do 2 plus h cubed times 2. So this is 2 plus h times 2 plus h times 2 plus h. So this is, let's do this, 4 plus 4h plus h squared times 2 plus h. So we're going to have 8 plus 8h plus 2h squared plus 4h plus 4h squared plus h cubed, and then all this times 2, right? So let's do this. 16. 8 and 4 make 12, so plus 24h. 2 and 4 make 6, plus 12h squared, plus 2h cubed. So this is just, we did all that because this is just that y value that goes right here, right? That's the y value. Now we have to find slope. So we take y2, which is this we just wrote, minus y1, that's 16, over x2 minus x1. So what happens? We get the 16s cancel, the 2's cancel, right? So we have 24h plus 12h squared plus 2h cubed all over h. We then can factor out an h. So we have 24 plus 12h plus 2h squared, and the h's cancel. And we're left with 24 plus 12h plus 2h squared, right? Which is what they asked us for. It's right here. Prove that that's what you get. We just did. Now, we're going to take this new term and evaluate a limit as h approaches 0. Well, if that's the case, you're just plugging in 0 for h, right? And you get 24. So our instantaneous rate of change is 24 at 2. Okay? So we're going to do this again on 112. So we have now 2 to the x. They want us to do it at 5 and then 5 plus h. Okay, so 5, so you put 5 into the function, so you would have 2 to the 5th, which is 32. and then you plug this into the function, you'd have 2 to the 5 plus h. Okay? And I'll help with that, right? So 2 to the 5 plus h. So we're going to do that. That's 32 times 2 to the h minus 32 over 5 plus h minus 5. So obviously the 5's canceled. The 32's cannot, okay? It does not work that way. You could factor it out, but it doesn't work that way. So say we factored out 32. You're then going to be left with 2 to the h minus 1 all over h. And it says what happens when h is 0. So when you plug in 0, you're going to get 0 over 0, which we already know is indeterminate. Okay, so what does this tell you, right? We can't determine the instantaneous rate of change at 5 here. Okay, but we could graph it, right? It says use a graphing calculator to evaluate, right? And we could get extremely close values and do it that way to get instantaneous. Okay? All right, and then in the homework problem 102, you showed average rate of change for 3x minus 5 is 3, no matter what interval. Okay, to investigate this, complete the parts below. So it says what happens when you plug in x plus h into the function. So let's do that. So we have f of x equals mx plus b. We're going to plug in f of x, which we know is mx plus b. So we have an x input and mx plus b output. Then we have an x plus h input, and that output is mx plus mh plus b. Okay, so now y2 mx plus mh plus b minus mx minus b all over x plus h minus x. So again, x's cancel, mx cancels, b cancels. So now I'm going to be left with mh over h. The h's will cancel. I'm left with m. So no matter what the linear function, if it's a linear function, my slope is my instantaneous or average rate of change. Okay, there's a math notes here explaining some average rate of change, instantaneous rate of change, and how we're moving that direction.